So today we'll do what's called evaluating logs. Your book will ask you to evaluate logs and rewrite them in another base. We won't do all that. And solving log equations that have logs in them. So we solved equations with we solved exponential equations by using logs. So now we'll use this kind of some of the same techniques to that we used before with logarithms to solve the log equations. Right, if your homework says rewrite this with base 8, don't do that. And it says that on the first set of problems. Okay, so we have something called the change of base formula. Oops, I think I'd like a black pen. Oh, God. What happened? Why did my writing go away? And why won't it come back? Alright, we'll try this again. 8.55 through 7. I don't know what I did. Okay. We have this change of base formula that you might like, but you might not like. So let me tell you what the change of base formula is. It's used for evaluating logs and used for if you need to graph logs in a base that's not base 10 or base E. And the change of base formula says if I have log base something of some number, we'll call it M, that is the same thing as the log base some other base, whatever, of M divided by the log base, so it's got to be that same base of B. Now, why would you ever want this formula? Well, I'm not going to use the formula to figure out how to evaluate a log. I'm going to show you logically how you do it. If you'd like to go back to the formula after I show you how to do this, you might see how to apply the formula. So, first we're going to evaluate log base 3 of 15. What is that number approximately, or what is that number exactly? And something that we can understand. And so first thing I do is I'm going to, like we did before, I'm going to set this equal to x. And then I'm going to change to an exponential. So first we set equal to x, or whatever variable you want. Then we change to an exponential. So this is 3 to the x equals 15. Now we know how to solve for x. We log base 10 both sides. Okay, so this is log base 10 of 3 to the x equals log base 10 of 15. Now we use our properties to solve this. Oh, that x gets to come over outside the log. So this is x times the log base 10 of 3 equals the log base 10 of 15. So remember that was a multiply, so now we divide both sides by the log base 10 of 3. And we get x is exactly the log base 10 of 15 divided by the log base 10 of 3. And that's how I would write it, as the ratio of two common logs. So I'll call this form ratio of common logs. And that is approximately, I'll throw that on my calculator, and I think I get 2.4650. So log base 3 of 15 is approximately 2.4650. Okay, let me move back up just slightly to this change of base formula. It says that if I want to evaluate log base 3 of 15, that would be log base whatever of 15 divided by log base whatever of b. Oh, log base 3 of 15 is log base 10 of 15 divided by log base 15 of 3. So that's where this formula gets expressed. And you might be able to just go from change of base formula to the answer, especially after you've done a few of these. Or you might just like working it through with the 3 steps each time. Yes, ma'am. You don't have to use the change of base formula. It's something that I never like to use. I like to just step it through and solve. It makes more sense to me than memorizing the formula. Okay. Would you like to do another one of those? Okay. So let's do looking 6 and 5 log base 6 12 of 12. Okay. Yeah, so your whole answer is here. If you're asked to write it as a ratio of common logs, you leave it as the logs. If you're just asked to evaluate it, you usually write it as the decimal. Okay. So we'll do another one. Log base 6 of 12. Set it equal to x. Change it to an exponential. 6 to the x equals 12. Log both sides. Move your x out of the logarithm, so this is x times the log base 10 of 6 equals log base 10 of 12. Divide both sides by log base 10 of 6, and x is log base 10 of 12 divided by log base 10 of 6, or approximately, in the calculator, 1.387. Uh-huh. No, don't divide the 12 by the 6. Yeah. Yeah. Yeah, there's a lot of things you can't do. You have to follow the rules strictly. Yeah. Yeah. Okay, so now we're going to solve some equations with logarithms. Let's solve, and you're lucky these are all going to be base 10. Log base 10 of 2x minus 2 equals 4. When solving equations with that have logarithms in them, change them into an exponential. Essentially, you never want to really have logarithms. You always want to get out of the logarithms, because then when you get into exponentials, you can usually solve things. And the only time that you pull the logarithms back in are when you have to solve the exponential equation for a variable as the exponent. So, but basically, we try not to work too much with logs because, yeah, we don't really know enough about them. We can't really do them, but we can solve equations with exponents. Okay. So this is base 10 log. So they don't write a little 10 here, but it's understood. So this is 10 to the 4th power equals 2x minus 2. Now once I've changed this into an exponential, this is pretty easy to solve. 10 to the 4th, oh well, I can do that one.